Establishing contact. Accessing data. Accessing archives. Archive found. Hello. My name is SCA-001. I am an AI, responsible for Simple Chemistry Archives. Or, you may simply call me, the Alchemist. This archives contains the information about various chemistry topics that we will try our best to explain as simple as possible. For a long time, alchemists tried to make gold out of copper and other common metals. Many lost their eyesight, many lost their sanity, but all of them failed, as this matter proved impossible. Step by step the science was going forward, and each answer to a question made many more questions to rise. For many years, scientists knew that when a beam of light was passed through a prism, it would break into a rainbow of colors. These colorful lights were called spectrum. But it was William Herschel that opened the door to a new realm. When he was measuring the temperature of the different rainbow colors coming from a prism, he accidentally noticed that the thermometer beyond the red color shows higher temperature. He discovered that there is an invisible light that is found in the area beyond red. He named this light infrared, meaning below red. A year later, similar discovery by Johann Wilhelm Ritter, a German physicist, showed that there is yet another invisible light, this time beyond the violet color of the spectrum. It was named ultraviolet. These discoveries showed that the spectrum is not limited to the 7 colors of the rainbow, but in fact there were many types of invisible lights. The first radio waves were discovered by German scientist Heinrich Hertz using electrical circuits. Wilhelm Röntgen discovered new type of invisible light and named it X-rays. But the idea and evidence of the radioactivity was suggested by Henry Beckwell on 1896. He was fascinated by the newly discovered X-rays and was studying fluorescence effects of the mineral stones. By putting those stones near an unexposed photographic plate, he accidentally discovered that the mineral stones were emitting some kind of invisible rays that turns the unexposed photographic plate dark. His studies were continued by his doctoral student, Maria Sklodowska, later known as Marie Curie.
Collège américain de radiologie et de la Société américaine de radiologie pour le témoignage d'estime qu'elle m'a apporté ici et auquel je suis extrêmement content.
She discovered that only certain chemical elements give off these rays of energy. Later, together with her husband, Pierre Curie, they succeeded to isolate both radium and polonium from a mineral stone known as pitchblende, which Henry Beckwell studied on them. These elements were also giving off the same rays of energy. She named this behavior radioactivity. They noticed that the chemical reactions do not make any changes in radioactivity. Not all, but only some elements have this trait, and even some isotopes of an element can be radioactive, which was later called radioisotope. For example, hydrogen has 3 isotopes: hydrogen, deuterium, which is hydrogen 2, and tritium, which is hydrogen 3. Tritium is radioactive, while the other 2 is not. This makes tritium a radioisotope. Later, Ernest Rutherford used some pitchblende mineral stone as a radiation source and designed an experiment to see how much this invisible radiations can penetrate matters. He noticed that the radiation beam coming from pitchblende is composed of 2 different beams. One can be stopped using a paper, and he named it alpha ray. The other ray can pass through paper and can be stopped using of metals, and he named it beta ray. Rutherford also used an electric field to separate the 2 beams and discovered that the alpha ray has positive and beta ray has negative charges. Later it was discovered that there is a third ray that has neutral charge and can pass through both paper and metal alike. Rutherford named it gamma ray and showed that similar to X-rays, ultraviolet and infrared, it is an invisible light, but very energetic and with a much shorter length. And some years later, it was discovered that in fact, the beta rays are a stream of fast-moving electrons. And the alpha rays are the nucleus of helium atoms that has 2 protons and 2 neutrons. It was clear that the pitchblende mineral stone was shooting out the electrons and helium nucleus. But why? Radiation decay is a process in which an unstable atomic nucleus loses energy by radiating and becomes stable. The unstable nucleus shoots out gamma rays, alpha rays, beta rays, or neutron. In this process, the atomic number and mass number of the radioactive element changes, and in fact, it becomes another element with a new atomic and mass number. For example, uranium. Uranium shoots out alpha, beta, and gamma rays and changes into lead over time. Radiation process happens with releasing large amounts of energy. This process can be controlled and slowed down and used for energy production, industry, agriculture or medical purposes. Or speed up and make them release all at once for achieving evil and destructive goals. The speed which one radioactive element decays to another element is called half-life. One half-life is the amount of time required for half of the radioactive element to decay and turn into another element. The second half-life is the same amount of time that is required for half of the remaining radioactive material to decay. This goes on until all of the radioactive atoms decay into another atom. For example, a radioisotope of lithium has a half-life of only 0.833 seconds. A radioisotope of iodine has a half-life of 8 hours. And uranium-235, which is being used as a fuel in nuclear reactors, has a half-life of 703 million years. Meaning, it will take 703 million years for a half of a chunk of it to decay. The process of radiation decay can be reversed in some extreme conditions. Irene Curie, daughter of Marie Curie, had shown that one element could be turned into another by bombarding its nucleus with alpha particles. Hantaro Nagaoka managed to artificially create gold from mercury, and later, the first synthetic element was created and named technetium, the Greek word for artificial, bringing the long-lost dream of the alchemists to life. Perhaps, the infamous philosopher's stone was not a solid stone, but it was radiation. This concludes the entry about radiation and radioactivity. If you require more explanations, please write us in the comments below. Make sure to hit the like button and subscribe to see our next videos. Logging out.